Hi everyone, in today's video we're gonna make something like this, a set of random boxes which mostly used in walls or pavements. So let's go. So from the previous videos we learned how to work with circles, and now it's time to get to know rectangles. I just add a rectangle into my Grasshopper view for now to start with. Okay, so as I said before, rectangles are just a little bit more complicated than circles, which we have worked with them before, but don't worry, it just doesn't mean that they're hard to work with, they just need a bit of mathematics. So for my rectangle here, I need two values as x and y, and it says we need to define a domain for each. To build a domain, I should just search for it and select construct domain, which allows me to make it by numbers. As you see, it contains a start and end number, and now the only thing I have to do is to add a number slider here and connect it to x or y value. Now what we see here is a single line moving in the domain. The point that is missing here is that when you're having a value for two edges, you should notice that each edge just goes the opposite direction of the other one. This means that if I go to one of the start or end of my domain and add a negative expression to it, then we can have one value for two edges. And as you guessed, we can have one value for all of our edges for a square. To have a more organized view, I can select each component I want them to stick together and group them. You can also make changes and explore in the visuals by right-clicking on the group. Now let's set this all to preview and move to our next level. We can have a basic surface in Rhino space and add it to Grasshopper as we learned in the previous videos. So I created it, and after coming to Grasshopper view, add a surface reference and set it just like that. In our last tutorial, we talked about dividing surface. We can work here with that tool, but I would rather to do something different. I want to make a grid on my surface, so this time I'm going to use divide domain, which divides both u and v coordinates for me. So as I said, we divide u and v by numbers, which, these numbers define the lines we have in each direction. After we finish working with divide domain square, you can't see any inner lines on the surface, and that's because we need another component named Isotrim. And then we just have to connect our surface and domain to Isotrim, and the grid lines appear. After setting the proper numbers, we need to find some points on the surface. So if you remember, we could use area to find center points on the geometry. And here is the reason why we didn't use divide surface, because in that case we could make some points also on the edges of our surface, which is not suitable for now. Another point is to connect the right geometry to area. See, if I just give the main surface straight to area, the result is just a single center point. Anyway, I just bring my square back and make some changes in the dimensions of it and prepare it to be located on the points. For the next step, we search for a tool that is used when we want to take a shape and place it on something else, which we have talked about it before, Orient tool. So I connect the square as my geometry and the centroids as my target points. Now if I zoom in, it's obvious that the shapes are not on the same plane as our surface. Now, fortunately, we drew the surface on an easy plane, so I should just search for XZ unit for now. But we know what we could do if the surface wasn't on a 2D plane. We could just use plane normal. But for now, just an XZ plane will work well. After connecting the right plane, you can check it in the perspective view and everything looks good now. I'm just gonna make some changes in my rectangle for a better look. You can also set any of your components to preview to see what's going on better and having a double check. Now, to make these rectangles come out of the surface, we need to extrude them. And if you remember from before, to extrude the geometry, we need a shape, a base shape, and a direction, which for here I use Y unit. So you see the extrusions go backwards. Now all we have to do is to give a negative expression to the direction here. Basically you can stop here, but this is not cool enough for me, so I want to use a random tool to give different values to my extrusions here. So after adding a random tool, you can see that it needs a domain, number, and seed. First of all, let's make a domain. So I search for construct domain, which helps me to make one by 2 values. Next, for the numbers, we should find the number of our extrusions. To do that, we should multiply the height and width number, which I search for multiplication. And after connecting U and V numbers, we have extrusion count. Finally, seed is the number of random algorithm it uses. So just needs number for now, and if you don't like how it looks in the end, you can just change the seed number. And finally, just connect random to Y unit. And just like that, you have a parametric wall. You can play with each number and compare the results and have fun with it. If you have any questions, feel free to leave comments, and thanks for watching. Bye.